This is the last section we're going to cover in this chapter. You have a straight edge there, and we're going to use it for the ruler. We're using it for the ruler, okay? Okay, so I'll leave out the story. Anyways, because we don't have time, because we had that fire drill. Okay, so we're going to find out, just by looking at a map, we're going to measure between Port Jacob and Southport, and if my map here tells me that for every ½ inch, it's 20 miles. Okay, and we're going to set up a proportion and all that, and figure that out. So what I want you to do is I want you to measure. Now, the thing about measuring, now some things you do need to be very exact, like when you're building things, and that one's, okay, that one will be okay. So be sure that across the bottom of your protractor there, that you measure, that you line up where the inch starts, and in your instructions it says measure to the nearest 16th of an inch. Well, that's how your little tick marks are, your tick mark there's are marked. If you count, there's 16 units in between each inch. So if you measure this, and in this thing about this doesn't have to be super exact, because we're just kind of, we want to know, hey, we're looking at a map, we want to know about how far those two towns are from each other, or cities, whatever. So if I count, it's over 1 inch, so I look at my 1 inch mark right here, and from there I start to count. I don't count that, I count the next one. So I go 1, 2, 3, 4, 5. It looks like 5 on mine. Some of you might have counted to 6. Okay, it's so close that I'm just going to go with 5. Okay, so right here I'm going to write 1 5/16. Okay, now I would like to work with that as a decimal, if at all possible. So how do you, now some of your calculator will automatically do that for you. It'll go right to decimal. But since I don't have the number in there yet, if I'll just figure the fraction part. So the fraction part is 5 divided by 16. Yes.
I don't understand how it's off 1 and 5.
Okay, well, it tells me that I'm going to measure this to the nearest 16th of an inch. Okay, so when I measured this, okay, so here's my 1 inch right here. Oh, sorry. I blew it up, so. Okay, so see where there's a glare on the 1. Okay, see how my 1 inch mark is right here. Okay, so I'm going to count so I get to the end of that line.
Oh, okay.
So 1, 2, 3, 4. Now see, now when I line it up, I get 6, but the first time I got 5. So your answers may vary just a little bit, but I'm going to go ahead and go with 5. So to find out, I want to find out what the decimal of that is. So if you'll just punch it in your calculator, 5 divided by 16 is 0.3125. Do not round that. Okay? We don't want to round it. There's nothing wrong. That's the exact decimal of that. So which is, so now just put the 1 in front of it, 1.3125. So this is the proportion that I'm going to set up. My map tells me for every ½ inch is 20 miles. So I'm going to do 0.5 over 20 equals, now, I have a hard time keeping this on there. So do you think this inches here that I just found, do you think it goes across from the 0.5 or the 20?
It goes across from the 20.
This is inches and this is miles. So it'll go across from the one that's also inches. And then how many miles that is what I'm looking for. So that's my unknown. So then when you cross multiply that, that's what I get. And then I'll divide that number that I just got by 0.5. Okay, so I get 52.5 miles. Okay.
Where'd the 20 come from?
Right here on my map. For every ½ inch is 20 miles. Okay, so I just use that. I could have flipped it. I could have put 20 over 0.5, but then I would have to flip this. Okay, but I just went with what I had, and then I determined where that my measurement went that I just found, my 1.3125. and the miles is what I'm looking for. Okay? Okay, so let's measure Port Jacob to Brighton Beach. Okay, so I don't know how far these cities are from each other. You don't have to draw a straight edge. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I counted to 12. 1 and 12/16. Okay, please do not try to put 1.12. That's not the same thing. Now, if it was out of, if there were 10 units between each inch, you could. But that's only when there's 10 units. Okay? So you have to put 12/16. So this one was 1 and 12/16. Now, if you got 11/16 or 13, that's how it's going to kind of, if you measured it. Or if you just want to stick with my numbers, I don't really care. So this time when I do 12 divided by 16, I do the fraction part, I get 0.75. So that's the same thing as 1.75. And so I go back to this first equation that I set up, and I just replace that number right there. So that's the number I'm replacing. That's where the 1.75 goes in that equation. Okay? So then I take my new number, my 1.75, multiply it by 20, and then divide by 0.5. So what do I get for x on that one? Because you can kind of follow this, the steps you took, right? You multiplied it by 20, and then in the next step you divide it by 0.5. So you can do that once you find your new measurement each time. Multiply by 20 and then divide by 0.5. That's what I got, 70 miles. Okay. Okay, Brighton Beach to Pirates Cove. It's kind of depending on where you put your pencil. You putting it right in the middle of the circle, or are you measuring it from the edge of the dot to the end? That's why we're not getting exactly the same thing. So let's see. 1, 2, 3, 4, 5. I got 5/16. 1 and 5/16. Oh, looky there. I already got it once, so I figure it again. So what was this one? Yeah, 52.5. Okay. And then we'll do East Port to Sand Dollar. I got 2. I got 2 even. We'll go with that. Okay, so if I got 2 inches, I'm just going to replace in my equation 2. So I'm going to take 2, multiply by 20, and divide by 0.5. Did you get 80? Okay. Okay. Moving right along. Any questions before I do that? Move right along. Okay. You're done with your. Okay. So on number 5, Sanjay is making a 139 centimeter long scale model of the Parthenon for his history class. The actual length is 69.5 meters. Okay. So the first thing that it's asking for, it's asking what's the scale of the model. Okay, so let's look at this. So we have 139 centimeters for 69.5 meters. Okay, that's what it's asking you for right there. But simplify it if it can be simplified. Now you might be a little confused. Say, oh, but it's a decimal in there. How do I do that? This is how you use your calculator to do that. Since this number's first, I'm gonna, there's like you can write it like this, or you can write it as a fraction. So whatever number's first goes in the numerator. So I'm gonna do 139 divided by 69.5, and I get 2. Okay, when I do that, that means 2 over 1. Okay, so that's how I'm going to do that. That's 2 centimeters for every 1 meter. Okay, so just set up your ratio and then simplify it. That's what it's asking you to do right there. Okay. Now, part B is asking you what's the scale factor, is what it's asking you. Okay, so it says how many times as long as the actual Parthenon is the model. Okay, so if we go from the Parthenon to the model, that's a reduction. Okay, so this number should be less than 1. So what I need to do is I need to take, it doesn't really matter, you could take the one that you just simplified, or you can take, I would think, take this one. Okay, now I need to convert. I need to convert that either to centimeters or meters. What do you think? You can almost guarantee you should, well, not guarantee, that's right. Probably your best bet is always to go to the smaller unit. Okay, so if we went to the smaller unit, Jennifer, how would we, what would we convert it to? Centimeters or meters? Which one's smaller? You know?
Oh, me?
Mm-hmm.
Centimeters.
Centimeters. So how many centimeters are in a meter? 100. Okay, very good. So for every, I'm going to write it over here. So for every 100 centimeters, that's 1 meter. So what do I need to do to this number right here to make it centimeters?
Times it by 100.
Times it by 100. So this is the same thing as 2 centimeters times 100. So I just multiply by 100 centimeters. Okay? So when that happens, you don't have units anymore. Okay, those cancel each other out. And then what does that simplify to? 1 over 50. So there's your scale factor. Okay. So the scale of the model, you keep the units. Now, if I would have converted those both to meters, I still would have gotten the same thing. Okay. So I would have probably had to get my calculator out, but I could have done that. Okay. So let's look at number 6. Very similar situation. So go ahead and see if you can figure out how to set that up. I'll give you a moment. Same process as the other problem. If you weren't sure, this is how you'd set it up. That's where you'd start. And then if you weren't sure how to simplify that, it simplifies by 3s. So you could do 9 divided by 75 in your calculator. And for those of you that maybe are using this calculator, now I think you know how to find the fraction, and that one right there. But if you're using a graphing calculator, once you have your number entered, which it is, then you go to your math button, which is right below your green alpha, and a list pops up. And in that list, the first thing is for fractions, and you just do enter, and that's 3 over 25. So if you didn't see that it simplified by 3s, then there you go. Or you could just double check yourself. So my scale for every 3 inches in my model, that represents 25 feet. Okay? And then in step B, we'll just convert it all. Are we going to convert it to inches or to feet? Which is a smaller unit? Inches. And how many inches are in a foot? Okay. So which number am I going to multiply by 12? That's already inches. Yeah. So we're going to do 25 times 12, which is 300. So I'm keeping this in the same order. So I'm going to do 3 over 300, which simplifies to what? Okay. Any questions? Right here, it was because I multiplied 25 by 12, and that's where that's where I got my 300 inches. Okay. Okay? Ready? Well, the 25, I'm converting this to inches.
Yeah, but like, why is it 25?
Because that was the problem. I mean, that's just the number in the problem. Because I started out with this, and this was simplified. And to do part B, I have, 3 inches over 25 feet. And I need to convert either inches to feet or feet to inches. And I think it's better to just go with the smaller unit, just because usually then I don't have a decimal within a fraction. Because I could have come up here and divided 3 by 12, but then you have this decimal, and then, but it still would have worked out. Okay? So it doesn't matter which way you go. So when I took my 25 and multiplied it by 12, that gave me all that. Okay? Okay. I apologize. I'm probably hurrying just a little bit since that slowed us down just a little. Okay, so now we're on number 7. Okay, I'm going to move through this kind of quickly because, and yeah, I think y'all will, none of my other classes seem to have a hard time with this, so, I mean, I know, read it real quick, because I know when you read it, you're like, what? I don't get it. Okay. But once you see one of these, you're like, oh, okay. And there might be a better way to figure this out. But you know me and I'm so visual, I have to draw this out. So what this is saying, now, what they're saying is, they're just going by how long the White House is and how wide it is. So we're just looking at, like, the space that it takes up. We're not talking about the height and all that, okay? So if we were going to draw that on a piece of paper, and we wanted to stay proportionate to the actual size, how do I draw that on a piece of paper? I can't just say an 8.5 by 11 is like your paper right there that you're writing on. That's 8.5 by 11. So how do I keep it within there? And it's not asking for the largest. It's just asking, everybody could have a different answer. Okay? So it's just asking, how could I fit it in there and still be similar? Now, okay. So this is 11 inches over here, and this is my 8.5 inches over here. Okay, now I don't want you to write, you can go ahead and finish this picture. So 168 feet would go against what, the 11 or the 8.5? If you're comparing your two numbers. Right, so my 168 feet will have to go along this side, and my 152 would go along this side. Okay, now this is what I don't want you to write down. I'm just going to show you something. Okay, so if I set up the proportion, and it doesn't matter, if I do 152 over 8.5, that's how I'll start it. I've told you before, there's 4 different ways you can set this up. So if I put 152 on top, on the numerator over here, I have to put 168 over here. Now, whether you simplify those or you cross multiply, still, when I do that, and I'll just divide both. If I do 152 divided by 8.5, which is on my left-hand side, and then I do the right-hand side, I do 168 divided by 11, they're not equal. Okay? So that piece of paper is not similar, that rectangle of the paper, and then the rectangle base of the White House, they're not similar rectangles. Okay? So I'm trying to make a similar rectangle on that paper that will be similar, that will still fit inside that paper. Okay? So I can't say I'm going to use 11 here. I've got to either go down to 10 or 9, and whatever I use on this side, then it will tell me how much room I have on the other side. Okay? So what I'm going to do is I'm going to start, and it's just kind of a guessing game. I'm going to say, well, maybe I can go 10 inches wide on my paper. Okay? So I'm not using these numbers anymore. Okay? So this is what I'm going to be looking for. Okay? I still have this paper, and that's how big my paper is. But I'm going to set up a different proportion here. I'm going to do x over, now you can write this down. I'm going to do x over 152. And if I do x over 152, this side I'm wanting to be 10. I do 10 over 168. Okay? So if I use 10 inches long, will it fit wide? Okay, well, I don't know. Let's try it. So I'm going to cross multiply. And then I'm going to divide both sides by 168. Does that fit?
No,
No, it does not fit. How come?
because it's greater than 8.5.
Right, it's greater. The dimension for this side is over 9 inches. It has to be less than, it has to be either 8.5 or less. Okay? So, I'm going to try again. So it's not a major thing to try again. I just replace that number right there. We could try 9.5 or 9. What do you want to try? Let's do 9. Oh, I heard both, so I heard 9 first. Okay, so I'm just going to swap out 10 for 9 and see if 9 works. And I will cross multiply. I mean, you could truly have to do this sometime. Maybe you have a class that you have a project on and you've got to be as accurate as you can. So I got 8.14 something. Okay, I'm going to cross that out because that didn't work. Okay. Now will it fit?
Yes.
Okay. So now I want you to be careful how you do these dimensions. So it's 10 inches by, now that's a long decimal, so I don't want you to put that decimal. So now some of you will convert to the mixed number, your calculator will. And if your calculator won't, this is something you can do. I'm going to take the 8 off, and I'll take the 8 off by subtracting 8. Okay, and I'll just go whatever your calculator does to figure the fraction for you. And it's 1/7. Okay, so my dimensions is 10 and 8 1/7 of an inch.
Wouldn't it be 9?
No. No, because my other side can only, well, if I use 10 inches on the long side, my width.
Yeah, so that's why you put 9. Because it goes with the 8.14.
Mm-hmm. But if I do 10 long here, I only need to go 8 1/7 this way.
Oh, alright.
Wait, so why do we keep the 10? I thought it was too big.
Oh, I'm sorry. I see what you're saying. I'm sorry. Yes, I'm sorry. 9. Yes, I don't know what I thought you were saying. But okay. Yes, 9. I'm sorry. You are correct. I should have done this when I tried a new number. I looked right there and I just saw that 10. Okay. Okay, so we're going to do something very similar on number 8. This time we have an index card. And it's 4x6. Again, you don't have to draw this. Some of you may already have this, what's going on in your head. So we have 4x6. That's a little index card. That's the size of an index card. And this first time we're going to do the state of Colorado. And obviously the longer side is going to go right here, 380 miles. And we'll do the 280 right here. Okay, so we're going to see how we can fit that on an index card. So what number you want to start with? We'll just go across the bottom again. You going to try 5 or 5.5? Okay, some of y'all are already trying, maybe some not. this is still the size, but I just marked that out for visual for me. So x is actually what we're going to look for here. So I'm going to put x over 280 is equal to 5 over 380. Cross multiply. And then I divide my 1400 by 380. Does it fit? So I get some long decimal. So the dimensions I'll have to use on the card, I get my number right there this time, 5 inches, and convert that to a fraction, which is 13/19. So 3 and 13/19 inches. And you may want to try a different number. If you and your friends like to compare your answers, but you start out with 2 different numbers, then you'll get different answers, and that's okay. So maybe you might want to get it as big as you can. Maybe, I don't know, I haven't tried 5.5. Maybe 5.5 is too big, so maybe you want to try 5 1/4. Okay. Okay, and then we're going to do it again, and this time it's Wyoming. And that if you were to draw that out, you could. So, I mean, I'm not going to change that any. So this will be 265, and I'll just try 5 again. And practically using the same picture. So I'll see if the 5 inches works. And I get 3.63 something, which is long decimal. And so my next card will be 5 inches by, and I'll figure out what the fraction is of that. 46/73. Okay. And that was for Wyoming.